Welcome, everyone, to the latest edition of the podcast series, Reimagining Mobility. I'm here with Arka Dutta from Fuel Cell Canada. He's the testing manager for us there. Arka, welcome to the podcast. Thank you for your time today.
Thank you for having me.
Tell me a little bit, testing. So many different things can be understood under testing, and now we're talking fuel cell, or specifically fuel cell stacks. So tell us a little bit, what is it that you do? What is it that you're responsible for?
Yeah, so we are here located in Vancouver, Canada, in Burnaby, which is the hotbed for fuel cell testing and fuel cell applications worldwide. So we jokingly call this place like the Silicon Valley. We call it the PEM Valley, like PEM Fuel Cell Valley,
because it's Valley, very good. I like it.
We have very all our team and the testing team, and also AVL FCC in general. There is a lot of highly experienced people and very well-known people in the fuel cell industry. So here in Canada for testing, within AVL, we are the only affiliate who does fuel cell stack testing. So we do PEM fuel cell stack testing from the smallest level we call subscale, which is a portion of a fuel cell, going up to a full module. So all that testing is done through here, and it's mostly R&D and very specific customer application testing. Yeah,
very good. So in the PEM Valley, is testing, sometimes testing, I feel, in the mobility space, maybe more in the traditional passenger or heavy duty truck space. I feel at times testing is somewhat the poor ladies and gentlemen that get a device, get a product, get a complete vehicle or a component and say, okay, sorry, I know you had 6 months planned, but now you only get 2 months. You know what? Get it done. Is that the same in the PEM Valley, or is that not quite the same?
Yeah, I mean, testing is testing. There are different kinds of testing that could happen. So one is you already have a product and you're just testing it for QA and stuff. The testing that we do here is very in the initial phase, mostly R&D testing, which means we are testing next generation R&D application fuel stacks. So for example, we often say here that now we are in land, air, and sea, because most of our customers now, our applications go on from it's so exciting because it's passenger vehicles, trucks, commercial applications, marines. We are working with large OEMs and flight applications, even outer space applications. So these require for very specific conditions. Like a condition for a flight is very different from a condition that a vehicle is operating, and so on. So the testing here is very tailored and directed towards what the application is. So I would say I'm very excited. It's very exciting.
Yeah, I can tell. It's good. I can see and feel and hear the passion. So that is awesome. So tell me a little bit in testing, right? In traditional testing that we do at AVL, that OEMs do, that suppliers do, it's oftentimes obviously heavily driven by equipment that either excites or energizes devices, by measuring equipment, taking more and more data that we're then analyzing, trying to accelerating age testing, durability testing, environmental testing. Tell me a little bit, when you're talking about fuel cell stack, again, from the smallest, maybe the membrane, all the way up to the complete stack, the complete system. What are some of the tools that are you using?
Yeah, so firstly, we are located together with our partners Greenlight. So Greenlight, as we know, we are actually in the same building even, which in itself is a very interesting fact, because how many companies around the world have a state-of-the-art lab besides a state-of-the-art testing equipment manufacturing facility? So Greenlight, as we know, they are right now the largest and the most trusted fuel cell testing equipment manufacturer, which is an AVL company, right? And AVL has more than 65 years of experience doing testing equipment and powertrains and whatnot. So this is like a perfect marriage. So we are just besides each other. All our testing equipment obviously then is coming from Greenlight and from AVL, which is well known, like standard in the OEM world. So we are using AVL automation systems such as Puma, Concerto, Cameo, etc. tagged along with very trusted fuel cell testing equipment, which is coming from Greenlight. And so it's not just about offering testing, but also about if we want to do a new kind of testing which is not available anywhere else around the world, we are tying along with Greenlight to get those sensors, those equipment specially designed for AVL to be the first company to have access to such kind of precision equipment for testing.
Mm-hmm. Very interesting, yeah. So if you look generally speaking in the automotive space or even in the mobility space, right, the big buzzword is how can we transfer physical testing into the virtual world, right? Almost in some cases, we have some customers that are trying to go almost 100% virtual or digital. Other ones have a clearly different, more maybe balanced, and other ones even more extreme. They want to stay with the much more physical-based testing. Tell me a little bit, what do you see happening over the next 5 years, specifically as it relates to fuel cell stack testing? Are you going more digital with more sophisticated modeling capabilities or models? Or is it always going to be a balance? Or are you saying, no, for stack testing, it really's got to stay all in the physical?
Yeah, that's a very good question, actually. Like that's happening all around in all the different kinds of testing. So similarly, also fuel cells are kind of going in that direction. The only caveat being fuel cells, although they have been around for a long time, but it is only like a buzzword from the last 5-10 years, I'd say. Especially when some main scale manufacturers such as Hyundai, Toyota came out with their own passenger vehicles, and then people, okay, fuel cells, but it has been around for longer. But because of the mass adoption now of especially EVs, and then the problem with EVs with long range and whatnot, fuel cell has come on much more strongly recently. With that, obviously, most traditional OEMs, they want to have as much as possible move to the virtual world so that they can do modeling and everything else. Similarly, in fuel cells right now, the thing is we don't have, in the industry, there is not as much data available as you would have for a traditional testing engines and transmissions. So the data we are building that, so based on as you get more data, the models get more sophisticated and more precise. So yes, there is a large move in that direction, and especially AVL having that whole data set that from the industry about what operating conditions traditional OEMs operate, plus the fuel cell operating conditions. We are combining these two in models. So even before we start testing, all our testing is based off modeling, which is also done in Vancouver. So we use the modeling data and then start, as I mentioned previously, from single cell MEAs in subscale, characterize it, and then see if the data matches what the model is telling us. And as we collect more data, we are making our models more precise. So sorry for the long answer,
but all good. It's good.
But the traditional OEMs, if they are using a known MEA, known application, known fuel stack, then it's easy that you would have that data for that model, and then you can go ahead and use it in your whatever testing you're trying to do. But if it's a new complete set of, let's say it's an AVL stack, a stack that we designed the data, surely we can provide models and data based on that. But if it's a new one, then firstly, the customer, they would probably need to get those model data and then later on use the models to their use. I hope that answers. It's not very straightforward, but yeah.
No, it's good. It's good. I get it. And I think the listeners and viewers will get it as well. So let me add on to that a little bit. I mean, the big thing, I think, generally speaking, with fuel cell stacks or fuel cell vehicles, right, is the life, right? How many thousands of hours of operation is a stack gonna last or gonna be able to operate at the characteristics that it is when it first comes out, right? Before degradation starts, et cetera. And I know we're going from 12, 15,000, pushing us into the 20,000 and more. Generally speaking, testing, what is the fuel cell stack customers that you're dealing with or we're dealing with? What are they mainly interested in testing? Is it the durability? Is it the consistency of the output or the efficiency and performance? Is it EMC related operation? Is it environmental? How well does it do in hot and cold? All of that. Shed a little bit light on that.
Yeah. Once again, I think that's an interesting question, because as I mentioned, that what's interesting is the different customers that we are working on are working in completely different applications. So the requirement that let's say a commercial truck manufacturer has versus someone who's trying to use it on a spacecraft is completely different. But that's also interesting because we have developed over the years a few of our own stack designs. We call them not very creatively Generation 0, Generation 1, and so on.
Everybody does it that way. I wouldn't worry about a fancy name.
Yeah. So our stack designs are basically a platform for us to offer our customers who can base off our technology and base it off that. So for example, a commercial manufacturer, truck dealer, his goal or their goal would be mostly, how can I obtain a large durability lifetime, plus also have a very good power density and long range consequently. So essentially, fuel cells, one of the reasons that it's coming in place right now is many people often confuse that, well, EVs are coming in, then why fuel cells? Well, essentially, fuel cell is an EV, right? So it's generating electricity, and then you have electric vehicle. But the problem with the modern day EVs is, as we all know, the range anxiety and the how long can your vehicle travel, and that's when a fuel cell comes in. When you have a fuel cell, and you have the same amount of fill up time with hydrogen as you would have a traditional vehicle, and you could go over 1,000 kilometers. So that, for example, is a key element for a commercial truck manufacturer, that how can he have the least amount of cost and the maximum amount of range that he could use. I would say it really depends and tailor-made for what they are expecting, but essentially, like a traditional battery system, it starts degrading the moment you start using a fuel cell. But then we think you have good enough life for about 10 years, depending on what your application is. On the other hand, like for example, quickly about the aircraft industry. So we have had many requests, and we are working on many interesting projects where we would try to reduce the bulk, because weight is a main factor for them. And thus EVs are not suitable in such applications, because you want more range, so you want more battery, you are increasing weight, and it's like you go around in circles. So one of the requests that we often get from customers right now, and we have been successfully able to offer them to some of the large OEMs around the world, is how can we have a fuel cell stack design and a system which is less bulky and essentially more light, at the same time offer you good degrees of efficiency while doing that. And it has to be, for example, air cooled and so on. So yeah, it really varies from the different applications.
Okay. If you take the different applications, so to lead or to add on to that you just mentioned, I mean, we're involved, right? Involved from anything from a stationary fuel cell based power system to fuel cells for heavy duty trucks, passenger vehicles, marine application, rail application, airplane and space applications. So really anything that moves, and even traditionally stationary produces power. What is the most exciting thing that you've tested over the last 6 months in any of those fields, or in one of those fields? Just which one was the one where you say, "Oh wow, this is pretty cool. I haven't done this," or "This is really unique," or "is super exciting"? Maybe share one of those cool or exciting stories.
Yeah. Well, I can definitely say that every time I think, well, this is cool and exciting, soon enough something else shows up. So it has been quite an exciting testing that we have been doing in the past. One that I could point out that we are currently working on is with a large OEM for airplane application, and what we call like a dead-ended testing, in which we are trying to test our own stacks actually and see what the performance is like and what's the efficiency when you have you have essentially closed off, like it's dead ended, so you're just flowing gas and it's not coming out the other end. So that testing was actually, we didn't have that capability in our test lab, and they required this testing to be done really, really quickly. We, as I mentioned in the beginning, having Greenlight besides us, and we just next door. So we quickly had chats with them and we discussed what we could do to help our customers on that. And we were able to modify our test beds really quickly. And we had our own stack design. So we had the models that you talked about previously, what we could expect. And this was interesting because we ourselves hadn't tested it, our own stack in such a condition. And we were able to modify the test beds, create test procedures, run these tests, even test working environment scripts and everything to do that testing. When we got the results, the customer was really happy that we could do it like so quickly. But on top of that, it was also cool for us to know like how our stack was actually performing in such a condition. And we were actually quite surprised that it was performing quite well. So, so that was quite interesting.
I think that's a great example, Arka, of technology leadership, ingenuity, flexibility, and adaptability, right? So that's great. So maybe to wrap this up, last question. What do you see in your specific department, and again, testing, right? What do you see changing, or what do you see as a major challenge over the next 3 to 5 years as it relates to specifically fuel cell stack testing?
Yeah, that's, I think in my opinion, in fuel cell stack testing, like any other testing, essentially you would as newer fuel cells and more fuel cell adoption is happening, there are two things which happens in all testing in general. One is newer materials and more advancement in material science brings up more kinds of different kinds of materials which we would and could need different ways of testing, creating different operating conditions. That is always a challenge, but also is quite exciting on how we can offer that. But the second thing is also, which is somewhat less talked about, I think, is essentially electrolyzers are also coming up quite around the world. Many governments and many countries are adopting that quite some. Like you said, fuel cells have the capacity, when combined with electrolyzers, is to be like in itself provide electricity off the grid in many places. So many countries are actually investing quite a lot in their electrolyzer testing, which is essentially like a fuel cell as well. So one thing that we see catching up quite a lot is helping our customers out and ourselves also in the electrolyzer business. So that one, along with new advancements in material sciences and MEAs and stuff. So we hopefully able to support our customers with that I think is coming up.
Okay, very interesting. Thank you, Arka, for your time. Very interesting. Thanks everyone for tuning in into Reimagining Mobility podcast series. Thanks everyone.
Thank you so much.
Thanks for listening to Reimagine Mobility podcast. If you like this episode, please subscribe and tell a friend.